Hi everyone, welcome back to the channel and welcome back to Win Some Mathematics. Okay, so we have to become fearless, we know, and we know that learning is fun. Okay, so just come to the question sessions. Okay, in this video, I will cover the second question. Okay. Second question. Yeah, that means I have already covered first question. If you haven't watched, please watch that video. Please check the description. That was the most important question because I discussed all the approaches like how to solve any question. Okay. So let's begin our question session that we have discussed it and we will discuss this question. You will be thinking only this. No, I have to cover all the question, but in this video, again, only this question. Okay. So these all are the questions that we have to cover and we will discuss with the same approach, same interesting approach. Just learn all the question instead of planning. Okay. So now coming to the question without wasting any time. So just see what is our question. Yes. 0 to 2a. 0 to 2a. This is the second question and x cube 2ax minus x square to the power 1 by 2 dx. Clear? So now just think that how to solve approaches are on your screen. So first identify limit. Like in the previous question, we know that what was our standard limit. Our standard limit was 0 to 1, 0 to pi by 2 and 0 to infinity. And why is this so? So again that's why I am repeating. Please watch that video. Okay. So simple I will tell you in brief because these are the limits that used in the definition of beta and gamma. So anyhow, we have to transform into the definition of beta mn or gamma n. Okay, simple. So this was our reason, and we will transform it by using what? Substitution. Okay, by using substitution. So what is our problem? Substitution. Yes. Substitution. What is our problem? Our problem is awkward limit. This limit we don't want to see 0 to 2a. Okay, this is awkward limit. So how to get rid of it? Simple, we have to do the substitution and we will substitute the variable of integration. So what is the variable of integration? X. And we have to substitute x is equal to something. So just think that what to substitute to transform this limit into this standard limit, either to 0, 1, either to 0 to pi over 2 or 0 to infinity. Okay. Then we will use the relation between beta and gamma wherever necessary. This is our third point and we know it. We have learned it in the previous video. Okay. Because when we will dive down into the calculation, simply we will recommend this step. Okay, simple. Now coming to the solution that x is equal to something. So I will put and we will put x is equal to what? 280. Now just think that why I did this. Why? Ask, yes, why is important? This must raise in your mind. Simple because we know our problem and we learned in the previous video that this is our problem. In the previous question, a square minus x square was term. So a square was our what? Problem. Why? Because we don't want to see the constant term. Why is this so? Because in the definition of 0 to 1, x to the power m minus 1, 1 minus x to the power n minus 1 dx. What is this? This is the definition of beta mn. So we know that to convert this integration into this integration, we need to remove this constant term 2a. That's why we will put x is equal to 280 so that 280 x is equal to 280 so that this will become 280. Okay, and this is also become 2a. So 2a, 2a, 2a square, again 2a square. Okay, so 4a square will be common, simple, and 1 will remain. Okay, because x will be also common. So one more step you can do. Simply first you can take common 0 to 2a x cube and x will be common. So 1 by 2 is the power. So x to the power 1 by 2 and 2a minus x. Now clear? Very clear? Dx. Now x is equal to 2a so that 2a will be common and 1 minus t will remain inside the bracket. Okay, so this was our main thinking step. Okay, so now just see that what we did. Yes, we substituted x is equal to 280. Why? This is very clear. 0 to 2a x to the power 7 by 2. How is this? So simple. 3 plus 1 by 2 here. 3 plus 1 by 2 7 by 2. 2a minus x, and dx is equal to 2a dt. This is very clear. Upper limit is 1 and lower limit is 0. Why? Because when x is equal to 0, so 2 is equal to 0. When x is equal to 2a, 2a cancelled and t is equal to 1. So when we substituted, we automatically come across the magical thing that we don't have to worry about the limit. It automatically get transformed from 2a 0 to 2a to 0 to 1. 0 to 1. Okay, and that is equal to 2a to 2a t. Sorry, 2a t. This is 7 by 2, and this is 2a minus 2a t, and this is 2a dt. Clear? Very clear, because dx is equal to 2a dt here. So our limit is cleared, our first step is cleared, we identified limit, we transformed it. Now everything is about just the calculation, because we know that we have to transform this integration now into this standard definition, okay, of beta mn. Clear? So what will we do? We will simply calculation, do the calculation 0 to 1, 2a to the power 7 by 2, and here 2a, here 1 by 2, sorry. Okay. And here 2a and here 2a is common. So we will simplify this 2a and this 2a. So 2a to the power 7 by 2, and this is plus 1. Okay. And again 2a is common. So this is power 1 by 2, and this t I will write here t to the power 7 by 2, and this is 2a is common, so 1 minus t to the power 1 by 2 dt. Clear? So now what will remain here? 0 to 1, 2a to the power 7 by 2 plus 1 by 2 plus 1. So 7 plus 1 plus 1. Okay. So clear? 7 plus 1 plus 1, 9, okay, by 2. So 2a to the power 7 by 2 plus 1 by 2. This is 4. Yes, and this is plus 1. Okay. 7 plus 1 plus 2. 7 plus 1 plus 2. This is 2. Okay. So what will here? So 7 plus 1 plus 2. 8 plus 2, because 2 is LCM. So 7 by 2 plus 1 by 2 is as usual. So 8 and plus 2, 10 by 2. So this is 2a to the power 5. Simple calculation, t to the power 7 by 2. 1 minus t to the power 1 by 2 dt. Clear? So now 0 to 1, 2a to the power 5. Clear? Because this is 5 10 by 2, and this is t to the power 7 by 2. So how will we frame this t into this definition, x to the power m minus 1, because nothing is in the form of m minus 1. So what will we do? Simple, we will do plus 1 minus 1, so t by 2 7 by t to the power 7 by 2 plus 1 minus 1. Similarly 1 minus t to the power 1 by 2 plus 1 minus 1, and this is dt. So clear? 2a to the power 5, so 32a to the power 5, and this is 0 to 1, so t to the power 9 by 2 minus 1, and 1 minus t to the power 3 by 2 minus 1, and this is dt. Clear? Crystal clear? Very good. So now what will we do? We will see that here integral become this type after substitution. This is very clear. So now we will solve it. So we will arrive to this beta 9 by 2 and 3 by 2. How is this so? Because 32a to the power 5, 0 to a, t to the power 7 by 2, we can write it 9 by 2 minus 1. And how is this so? 9 by 2 minus 1. This is simply by doing plus 1 minus 1. So just learn it. Okay, 1 by 2 plus 1 minus 1. So that this will become n, and this will become m, and this will become n. Okay, so n minus 1 and m minus 1. Clear? So our value is very clear, beta mn. So 9 by 2, this is 3 by 2. And now we will use our third step. So we will use the relation between beta and gamma, because we cannot further evaluate it without using that definition. Okay. So clear to you? So we will use it. Okay. So our beta 9 by 2 comma 3 by 2. And 32a to the power 5 is multiplying. Okay. So don't worry for this. We will write it in the next step, because this is multiplied. So we know that beta mn is equal to, what is beta mn? Beta mn is equal to gamma n upon gamma m plus n. So we will write this directly 9 by 2 gamma, okay, and gamma 3 by 2 upon gamma 9 plus 3, 12 by 2, that is 6. Okay. So how will we calculate it? I already told you in the previous lecture, in the lecture of gamma function, that how to solve this gamma. Okay, so this is greater than 1. We identified it, so we will use 1 plus something. That is 1 plus n, and must strike in your mind gamma 1 plus n, which is equal to n gamma n. Clear. And we know also the trick that how to write 9 by 2. We have to, first I will show you by writing 1 plus 7 by 2. So 1 plus 1 by 2, clear. And this is 5 factorial because gamma n is equal to n minus 1 factorial. Clear. So this is 7 by 2, gamma 7 by 2, and this is 1 by 2, gamma 1 by 2, and upon 5 factorial, this is 120. Clear. So n gamma n, here n is equal to 7 by 2. Clear to you. Here n is equal to 7 by 2. Here n is equal to 1 by 2. So n gamma n. 7 by 2, gamma 7 by 2, 1 by 2, gamma 7 by 2. Now we will use the trick because we know it. So simply we will write this 7 by 2 and numerator minus 2. Very good. 5 by 2. Numerator is 7. Again minus 2, 3 by 2. Again minus 2, 1 by 2. Now we will stop because we know that 1 by 2, gamma 1 by 2 is the last step. So gamma 1 by 2 root pi. And this is 1 by 2 and gamma 1 by 2 is also root pi. So this is upon 120. Clear? Very good. Now what will we do? We will multiply it by 32 a to the power 5. Clear? So how is the calculation? 7 into 5 into 3, and this is pi, and upon 120 into 1, 2, 3, 4, 5. So this is 32 and this is 32 a to the power 5. This cancelled with this, and 15 a to the. Okay, so this is our answer, 7 pi a to the power 5 upon 8. Clear? We we use the relation between beta and gamma because this is our third step. Clear to you? This is the relation, and we simply did the calculation as I told you. So this was all about this gamma 9 by 2, 1 plus 7 by 2, and 7 by 2, gamma 7 by 2 by recurrence relation, and again we use the trick to simply to evaluate it, and this is our final result. So thank you for staying so long. Okay, and we will watch the next question in the next video. Okay.